In this lesson, we're going to evaluate composite functions given the graphs of functions. And so this is what it's going to look like. So if you look at this example, you're given two graphs. So here's the graph of the function g of x, and then the lower graph is the graph of the function f of x. And what you want to do is you want to find the composition of functions f of g of 3. So remember, when finding f of g of 3, you have to look at the innermost function first, right here. So you got to find g of 3 first. And so to find g of 3, remember what that means. So to find g of 3 means this. All right, so g of 3 means what is the y value? What is the y value when x equals 3? So remember, this is your x right here. That's x. So when x is 3, and remember that you're looking at the graph of g now. Don't use f. You're looking at g first. All right. So if you need to, cover up the bottom part so you don't make that mistake. So g of 3. So you go to the coordinate plane, and so when x is 3, here's the point right here. So that y value is 2. And if you need to write it out, make sure you do that. So on your graph, if you need to, label the point right here. Label that point. So that's the point 3, 2, right? 3, 2. So now what you found is that when x is 3, the y value is 2. So this becomes now f of 2. Okay? So to find f of 2, you're going to go to the function f. And so here's the graph of the function f. So if you need to, cover up the graph of the function g. So here's the graph of the function f. And so just as we talked about here with this one, f of 2, remember what that means. F of 2 means when x equals 2, what is the y value? What is the y value? So when x is 2, so here's where x is 2, so the point of the graph that corresponds to that is this one right here. All right, so when x is 2, that point right here has coordinates 2, negative 4. That's important to see that. All right, 2, negative 4. And so f of 2 then, so what is the y value when x is 2? The y value is negative 4, right here, negative 4. So f of 2 equals negative 4. So we have now is this. We have, going to remove this, we have f of 2 is negative 4. So therefore f of g of 3, so your answer, I'm going to say f of g of 3 is going to equal negative 4. All right, and so it's very easy. It's very easy, just like it was easy in the previous lesson when you had tables. Graphs work the same way. Remember, the graphs is just a set of ordered pairs, just like the tables are a set of ordered pairs. All right, so that's number 1. So let's look at number 2. So number 2, the same idea. So you're given two graphs, same process, nothing difficult at all. So let me go ahead and rewrite this here. So we want to find g of f of negative 3. So we want to compose those two functions. When looking at this notation, remember when trying to find out what this is, you got to look at the function that's within the outermost parentheses, so the inner function. So we need to find what f of negative 3 is. So remember f of negative 3, what that means. So f of negative 3 means f of negative 3 means what is y when x equals negative 3. So we have to go to the function f though, so make sure you're using the correct function first. So the f function, the graph of the function f is down here. So let's go ahead and cover this part up so we don't look at the wrong function. So f of negative 3 So I go to my coordinate plane, and here's where x is -3 right here. So the point corresponding, the point that's on the graph that corresponds to x equal -3 is this one right here. So let's go ahead and label that. It helps if you label it. So the coordinates of this point is -3, -4. X is -3, y is -4. So -3, -4. So going back and answer the question, what is y when x is -3? When x is -3, the y value is -4. So this becomes right here -4. Okay. So what that means then is this. I'm going to move this out of the way. What that means is that this right here is -4. So now I've got to find g of -4. So now I'm looking at my function g. So I'm going to cover this up and look at the function g. So here's the graph of the function g. So when x is -4, the question is, what's that y value? So here's where x is -4, right here. The point on the graph corresponding to that is right here. See, right here. And so let's go ahead and label that. So when I label that, that's going to be -4, 5, right? -4, 5. And so when x is -4, what's that y value? That y value is 5. So that equals 5. And so therefore, g of f of -3, so your answer, g of f of -3 is going to equal 5. Okay, so that was number 2. Not a difficult process. It is fairly easy to deal with. Number 3, okay, we have this for number 3. So the graph on top is the graph of the function g of x, and this one is the graph of the function f of x. And you want to find f composed. Remember, open circle means composed, but you have to remember what that definition is when you're dealing with composition. So remember, f composed with g at 0, by definition, is f of g of 0. Okay, f of g of 0. And now that looks like numbers 1 and 2, that notation. And so when determining this, we need to first of all figure out what that innermost one is, so g of 0. So I'm looking at my function g right here, right? So I'm going to cover this up. So remember, right now, I'm looking at g of 0, g of 0. So remember what that means. That means when x is 0, what's my y value for the function g? What's that g value? When x is 0, here's the point corresponding to, see that's 0 right here, right? So here's the point of the graph corresponding to x equals 0. If you label it, and it helps to label, this is 0, 4. So what I found is that when x is 0, my y value is, see this is 0 here. When x is 0, my y value is 4. So g of 0 is 4. Okay, that's this. So now that becomes f of 4. Okay, and so now I go to my function f. So here's my function f. And so when x is 4, so here's where x is 4, right? Here's the point corresponding to x equal 4 on this graph of function f of x. So when x is 4, what's that y value? Well, that y value is -3. So f of 4 equals -3. So therefore, this f composed with g at 0, so you answer, you're going to say f composed with g at 0 is equal to -3. Right? It's a very easy process, right? Not difficult at all. Let's look at number 4. So number 4, same thing. So you have the graphs of functions f of x. So f of x is this graph right here, and g of x is the graph above. The g of x is the function whose graph is here. And so you want to evaluate the composite functions. So f, remember open circle means composition. So f composed with f at -1. So first of all, let's talk about that definition. So by definition, this becomes g of f of -1. So now we got to find f of -1. So remember, f of -1, cover up this part and just look at this for right now. f of negative 1 means when x is negative 1, what's that y value? But I've got to go to my function f. That's this one here. So when x is negative 1, there's that y value right here. That y value is 1. So if you need to label it, go ahead and do that. So this point right here is negative 1, 1, right? Negative 1, 1. If you have to label it, label it. Negative 1, 1. And so therefore, see, this is your function f, so you got to use f. So therefore, f of negative 1, the y value is 1. So when x is negative 1, the y value is 1. So this right here becomes 1. F of negative 1 is 1. So it becomes g of 1, right? And so now I've got to go to my function g. I have to go to my function g, which is the graph above. And this says when x is 1, what's that y value? When x is 1, here's where x is 1. Here's the point on the graph corresponding to that x equal 1. So that's 1, 4, right? So when x is 1, our y value is 4. So this becomes 4. And so therefore the answer, you're going to say, let's say you're going to say g composed with f at negative 1 equals 4. Okay? And so that was letter A. All right, let's look at letter B. Now for that, let me go ahead and erase this part so there's not too many coordinates listed. So I'm going to go ahead and erase all of this. All right, so let's look at letter B. Okay, so now f of 5. We got to find f of 5 first, right? So remember, you're finding f of 5. That's what you're finding, f of 5. So if you need to cover some things up or write some things over somewhere else, then do that. So f of 5 means when x is 5, and you got to go to your function f. So that's this one right here. Okay, when x is 5, what's that y value? So locate on the x-axis where x is 5, and the point corresponding to that is right here. So label those points, label them. So that's 5, 1. So when x is 5, my y value is 1. So therefore, f of 5 should be what? When x is 5, what's the y value? It is 1. So f of 5 is 1. Okay, so now since I found f of 5, this right here is 1, right? So that becomes g of 1. Now I've got to go to my function g. And where we see the x value, I've got to find out what the y value is. So when x is 1, here's where x is 1, right? Right here, x is 1. The point corresponding to that is right here, and that is 1, 4. So g of 1, when x is 1, my y value is 4. So this becomes 4. And so therefore, the answer, you're going to say g of f of 5 is equal to 4. Okay? For C, and again, let me go ahead and erase all of this. Okay, so now we're going to find, remember, open circle means composition, so F composed with G at 0. So that, by definition, that's F of G of 0. All right, so I know I've got to find G of 0 first. So I go to my function G. So if you have to cover up the bottom part, the graph of F, then do that. So G of 0, so when x is 0, what's the y value? So here is where x is 0. See, x is 0 here. So the point corresponding to x equals 0 is here. Okay, so that when I label that, that is 0, 5, right? So when x is 0, my y value is 5. So g of 0 means what is y when x is 0? So when x is 0, my y value is 5. So that becomes f of 5. So g of 0 is 5. Now I'm going to go to my function f, which is the bottom graph. And the question is when x is 5, what's that y value? So here's where x is 5 right here. There's the point corresponding to it. That is 5, 1. So when x is 5, my y value is 1. So it becomes 1. So therefore, your answer, you're going to say f composed with g at 0, f composed with g at 0 is equal to 1. All right? And then finally, letter D. So let me go ahead and kind of do that one on here. So f of g of 2 is what you want to find. All right, so let's see. So remember, the first thing you're going to do is going to find the innermost first, so g of 2. So g of 2 means when x is 2, and you got to go to your function g, that's this right here. When x is 2, what's that y value? So here's where x is 2, right? That y value right here, you can see it's 2. But if you need to label your points, then do that. That's 2, 2. So when x is 2, the y value is 2. So g of 2 is 2. So it becomes f of 2. So now I'm going to go to my function f, which is the bottom graph. And the question is when x is 2, what's that y value? So when x is 2, that's this point right here that corresponds to that. If I label it, and most of you don't, you can see that the y value here is negative 2, but sometimes it helps, 2, negative 2. So when x is 2, the y value is negative 2. So that becomes negative 2, right? And so therefore, f of g of 2 equals negative 2. Okay? So that's going to be letter D. So let's go ahead and rewrite that over. So this became, remember, g of 2 was 2, so that becomes f of 2. And we found f of 2 to be negative 2. And so therefore your answer, you're going to say f of g of 2 is equal to negative 2. Okay? All right, and let's do one more. So this is going to be number 5. So number 5, and there are 3 functions here. So here's the graph of the function f of x. Here's the graph of the function g of x. And then here's the graph of the function h of x. All right, so there are 3 functions. I'm going to try to decrease the size so all of them will show up. Okay, that's the best I can do without getting too small. Okay, so f of x, g of x, h of x, right? All right, so let's find f of 2. So the first one we'll find is g of f of 2. So first of all, let's find f of 2. So remember how to find f of 2. So you got to find f of 2. So remember, you're going to go to your function f. So there's the one that's a function f. When x is 2, what's that y value? So notice when x is 2, here's that point right here, right? So if you need to put a dot there, put a dot there. So when x is 2, that y value is 4. If you need to label it, label it. That's 2, 4, isn't it? See that? 2, 4. So that becomes, so f of 2 is 4. So now I need to find g of 4. So now I got to go to my function g. So here's my function g. So in the function g, when x is 4, what's that y value? Well, you can see that y value is 2. And if you need to label that point, label that point. It doesn't hurt to label the point. So g of 4 means what's that y value when x is 4? But remember, you got to go to your function g now. When x is, because this is g, when x is 4, my y value is 2. So this becomes 2. So therefore the answer, you're going to say the answer is g of f of 2 is equal to 2. Okay? Let's look at the part B. So part B says you want to find f of h of 2. So now let's talk about h of 2. So we got to find h of 2, right? H of 2. So I go to my function h, and where I want to find what's the y value when x is 2. So here's your function h right here. So when x is 2, here's a point on the graph corresponding to x equal 2. The coordinates are 2, negative 2, isn't it? So h of 2, when x is 2, what's that y value? That y value is negative 2. So now we know h of 2 is negative 2. So right here, that's negative 2. So this becomes f of negative 2. Now I've got to go to my function f now. So when x is negative 2, what's that y value on the function f? So here's the function f right here. X is negative 2, right? So that's this right here. The point of the graph corresponding to that is this point here. So that's the coordinates negative 2, 4. So f of negative 2, and put that here, f of negative 2, so what's the y value when x is negative 2? Well, when x is negative 2, the y value is 4. So it becomes 4. So therefore your answer, you're going to say f of h of 2 is 4. Okay? All right, C. All right, see, now notice that it's a different notation than the first two, so you got to remember that h composed with f at 2, by definition, means h of f of 2. All right, so now we got to find f of 2. So f of 2, I go to my function f, and where we see the point where x is 2, I got to find that y value. So when x is 2, go to function f, and I already have that point labeled. When x is 2, that y value is 4 in it. So this becomes h of 4. So now I got to go to my function h, and I got to find that y value. Well, when h is 4, which I already had that point labeled from a previous problem, when x is 4, oops, I'm sorry, I went to the wrong function. That's g of x. So I got to go to h, excuse me. When h is 4, this function here, when h is 4, I'm sorry, when x is 4 for your function h, so here's 4 right here, right? Label that point. When x is 4, here's 4. Label the point. You get 4, negative 4, right? 4, negative 4. So h of 4 means what's that y value? What's that y value when x is 4? Well, it's negative 4. And so therefore the answer, h composed with f at 2 equals negative 4. And then finally, h of f of 4. So we go through that process again. So f of 4, oops, I gotta fix this because the graph is, the point on the graph is way up here. So let me go ahead and fix this real quick. Okay, so I had to change that, and I'm hoping you saw the reason, because f of 4, here's the function f. When x is, oops, when x is 4, it's up here, and you don't actually see a point there. So I needed to change that to h of g of 4, and so we can now easily figure that out. So g of 4, so remember g of 4 means what? I'm going to go to my function g, which is this one right here. So when x is 4, what's that y value? So here's the point of the graph corresponding to 4, x equals 4. So when x is 4, that y value is 2. So it becomes 2, right? So that's h of 2. Now go to my function h, which is this one here, see h of x, and the question is what's the y value when x is 2? So when x is 2, I already have that point listed or labeled. When x is 2, that y value is negative 2. That becomes negative 2. And so therefore the answer, you're going to say h of g of 4 is going to equal negative 2. All right? And so that is the lesson on evaluating composite functions given the graphs of the functions. It's not a difficult lesson. It's fairly easy to understand. So that's the end of this lesson.